Okay, so good morning. So, 1 minute. Okay, now it is better. So, I hope you enjoyed that epsilon n method that we covered last time. So this epsilon is the size of the neighborhood, right? You need to keep in mind. So you change the epsilon, the value of number capital N will change, right? Okay. So for any sequence, if it is convergent to some fixed point L, so so there are two ways. So basically, you need to show that after some number capital N. So once you fix epsilon, right? Once you fix epsilon, basically, you can find capital N. After capital N and N plus 1, N plus 2, and so on, all terms of the sequence will lie in the neighborhood of that number capital L, right? Before number capital N, the terms of the sequence may go outside the neighborhood or wherever it is, we don't care. But once we cross that capital N, everything falls in the neighborhood of L. That is the key idea about epsilon N method. It's a very beautiful method. So we say that a sequence is convergent, a sequence of real numbers we are talking about right now. A sequence of real number is convergent if if limit n tends to infinity, xn or sn, whatever you denote, exists, right? And it's some fixed value L. A sequence is divergent if this limit does not exist, right? And I think I have shown you an example of such kind of sequence as well. For example, minus 1 raised to power n, limit n tends to infinity, does not exist, right? So you can see why. Because suppose limit exists, you can arrive at contradiction by using this epsilon n method, right? So whenever you are trying to prove that limit does not exist using epsilon n method, you assume that the limit exists, call it some number L. Then, since the definition should be true for every epsilon, you choose the epsilon for which you arrive at a contradiction, right? So you may ask the question, how do I choose epsilon? Who tells me? Basically, for that you require observation. All mathematicians observe the beauty, right? So you just observe the beauty. Okay, what is that epsilon that I should take? That will work for us, right? So that is a key idea. Now, so we have this, so 1 by 2, 1 by 3, 1 by n, that sequence we talked about, and limit n tends to infinity, 1 by n is equal to 0, right? So now the question is about series. Many people are confused between sequence and series. I mean, I think sequence is terms, right? First term, second term, third term, and so on. So basically, sigma, there is no sigma there, basically, right? And then when we talk about series means sigma, say 1 by n. This is a series. 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, and so on up to infinity. There is a summation between the terms, right? So if you put summation sign between the terms of the sequence, you get series. That is the key idea, right? For that, right? So then we can talk about convergence of the series as well. Okay, just like that, we say that a sequence is either convergent or divergent. If the limit exists, it is convergent. If limit does not exist, it is divergent. In a similar manner, we can talk about series convergence. So now, how do we talk about series convergence? Okay, so let me give you. So basically, what you do, you take the terms, first term of the series, second term, third term, and so on, right? So basically, you take n terms, partial sum, we call it partial sums, and take the limit as n tends to infinity. If n terms, sum of the n terms approaches towards a limit, then we say that the series is convergent. Okay, so let me give you proper definition. So this was all sequence. By the way, good that many of you were able to obtain the solution of this, right? This is known as audioactive chemistry. Okay, this work was done by John Conway. Anyway, So we talked about sequence, SN, and this neighborhood business, right? So remember, you should, whenever you are revising this concept or whenever you are actually trying to understand this, you need to do at least, you should need to understand two kind of examples for the convergence of a sequence and divergence of a sequence using epsilon and method. That is a very, very important thing, right? These two things are important anyway. Okay, now we are ready to describe what is known as series. Okay. So suppose we have A1, A2, A3, A1, A2, A3, AN, AN plus 1, so on. This is a sequence, right? But when I put summation here, so suppose I sum. There is some problem in this. I don't know how to write it properly actually, but it will not allow you to write. This is a series, right? You keep on adding all the terms. So essentially, there is a shorthand notation k is equal to 1 to n ak. This is sum of n terms. A1 plus A2 an, right? Sum of n terms of the sequence, right? I mean of the series. Okay. So this is known as infinite series, right? So we basically, in other words, we say that, so basically a series is convergent if sum up to n terms, so basically, so, okay, so this can also be written as summation n is equal to 1 to infinity an, right? Summation n is equal to 1 to infinity, right? A1, A2, A3, you can keep on summing, right? Summation. So when we say the series is convergent, so basically we are able to find the sum of n terms, n is equal to 1 to infinity, is nothing but limit n tends to infinity, Sn, which is sum of n terms, right? If this exists, we say that series is convergent, right? So you see, this is summation n is equal to 1 to infinity. We just take the, so we are looking at infinite series of real numbers. We just take sum of n terms, and this will nothing but a sequence, right? I call it Sn, sequence of real numbers, right? So basically S1 will give you first term, S2 will give you sum of two terms, S3 will give you sum of three terms, and so on, right? If this limit exists, as n tends towards infinity, we say the series is convergent, right? Now, as you know, when we talked about this limit, we can always talk in terms of epsilon delta, or right, epsilon n here. So can you give a definition in terms of epsilon n for a series to be convergent? It's very easy. If for every epsilon positive, there exists capital N integer such that mod of Sn minus L, where Sn is sum of n terms, right? Then only everything is fine, right? That is how you can form the definition, right? If you understand what is going on, forming definition is very easy, right? What? Got it? So this is how. So we can say that if for every epsilon positive, there exists n such that mod of A1 plus A2 plus AN minus L is less than epsilon for every n that is equal to capital N. Right? This is how the definition. And we know that this is Sn, sum of up to n terms, right? Any question at this point? Because many people are always confused what is sequence, what is series. Everything is crystal clear. If you don't ask any question, so everything is clear to you, or you don't understand anything, right? These are the two options, right? Or you have some fuzzy thinking also. Maybe true, maybe false, I don't know, right? Anyway, so just ask questions, as many as possible, because that is what everything is otherwise available on YouTube, this and that, book, right? If you read it, if you do think, it will be easy. Anyway, so this is a series. So now the question is, yes. Yeah, so convergence, a series is convergent if sum of n terms has a limit. Full stop, right? And when we say that has a limit, as n tends to infinity means we can write in terms of epsilon n, right? Because we know what is the meaning of limit of a sequence, right? So if the sequence of the partial sum has a limit, we say that the series is convergent. Got it? I think 30% लोग different medium से तो English समझ में आती है. Okay. No, I was looking at the survey, so based on that, because accordingly I have to, change sometime. Okay, so this is the thing. So question is, give an example of, I need to talk about few examples, right? About the series. So sigma 1 by n, is this convergent or divergent? Divergent. So 1 plus 1 by 2 plus 1 by 3 plus dot dot dot. If you. So beautiful T time problem is, how do you show this using epsilon n method, that this series is divergent? By the way, you can use some clever method also. How do you show that 1 plus 1 by 2 plus 1 by 3? Remember, I gave you this series up to n terms and with respect to your electronics business, right? Last time, if you remember. So how do you show that the series is divergent? This is bit something you need to observe. So basically, I can give you some examples. Summation is equal to 1 to infinity. This is divergent. Divergent means limit does not exist. Okay, the series is divergent. But if you put minus 1 raised to power n and then put n, this series becomes convergent. Beautiful thing, right? Moreover, if you increase the term, what about this series? Sigma 1 by n square. Convergent or divergent? Divergent? Sigma 1 by n square. ये सब तो जेई में पढ़ाया गया होगा, right? Sigma 1 by n square. Convergent means you can find the value, right? So basically, you have to say that take certain number of terms and n terms, right? And try to see if the limit exists, right? That is the key thing. By the way, this series is convergent. Not only that, there is a beautiful result to show that this value is pi square by 6. Now, how will you show that this value is pi square by 6? You need to become Ramanujan, right? By the way, there is a nice movie, I think on YouTube, Ultra Movie Parlor, right? You can watch Ramanujan, right, series. So he used to, with respect to pi, he was very passionate, right? And he used to write a lot of series which will give you value of pi. For example, this series can be used to find out the value of pi, right? You take 6 on the other side and just the value of pi will be as good as n approaches towards infinity, right? So those kind of things are there, right? So how do you arrive this? There is a nice trick to sum this series. And I think that I have given you in the sample paper. If you remember, sample salt paper, I have given you an answer to this problem. How do you show that this is pi square by 6? But before looking at the sample paper, I request you take a cup of tea and see if you can sum. How to find sum? That's a beautiful thing, right? Sum of a series, sigma 1 by n square, right? Uh, I can do tons of examples. There are so many things, but what is important right now. So you understood the epsilon n method for sequence, and that thing can be extended for series, right? So that is up to that point. It is clear. Now I'm going to give you some tests which are very, very important. Remember, each of these tests can be proved and have been proved by a lot of mathematicians using your epsilon n method. So if you are extraordinary mathematician, someone here sitting in the room, they can try to prove it using epsilon n method. Otherwise, as engineering students, it is sufficient to know those tests so that you can apply. But remember, if you just memorize the formulas to apply it somewhere, fine. It will work in some cases. I mean, for example, I try to give many problems for which all these formula will fail, and you have to think. So I encourage you to develop that thinking, right? How do you prove something? Anyway, so that is there. Let me show you some tests now. By the way, one very important thing: if a series is convergent, uh, the nth term of the series goes towards 0. Do you agree with this? Why? No, but what is the proof? It's a very simple thing. You see, I'll show you. So we say that if series n is equal to 1 to infinity is is convergent, if this series is convergent, then limit n tends to infinity, an is what? 0, right? And why is that? Okay, so basically, if you take sum up to n terms, okay, an can be written as, I should do it like this, a1 plus a2 plus a3, an is sum up to n terms, right? And a1 plus a2 plus a3 sum up to n minus 1 terms, correct? So Sn minus 1 is how much? An. And now if we take limit n tends towards infinity, this value will be, say L. If this is convergent, say converges towards L, this will be L. And what about this? L. So overall thing will be 0. Yes. I am just giving you one simple observation. If the series is convergent, another term goes towards 0. That's all, right? And the observation is very simple. Take sum up to n minus 1 terms, sum up to n terms, subtract, value you will get the nth term. And if you take the limit n tends to infinity, because if you take sum up to n terms, or sum up to n minus 1 terms, or sum up to n plus 1 terms. If the series is convergent, the limit will be the same, right? I'm just using that fact. So limit n tends, because series is convergent, Sn is what? Sum up to n terms. So that limit will exist. Call it L. So limit n tends to infinity, Sn will be L. Similarly, limit n tends to infinity, Sn minus 1 will be L. So L minus L is 0. Left hand side, and right hand side is limit n tends to infinity An, which is the nth term. Okay. What about the converse? I have shown you only one side. If the series is convergent, nth term goes towards 0. Simple observation, beautiful observation, right? What about the converse? If the limit of n tends towards infinity is 0, can we say that the series is convergent? So provide a counter example as a t time problem for you. Sigma 1 by n, right? The series is divergent, right? But the nth term goes towards 0, right? Very good. Got it? Okay. Right. So this is something, just beautiful observation. Take cup of tea, right? And sit down and then you observe. Now, basically, so I'm going to now list some tests. Probably it will take me about 15 minutes to write some of the basic tests without any proof. Okay. And I encourage, if you are overexcited and so on and so forth, you can try to do it using epsilon n method. Even if you don't do, it's okay. But you know, it all depends. Kisi kitni shraddha hai, right? So based on your shraddha, you can do it, right? So let me mention some of the tests. Okay, so suppose we have An. This is the series. Now, this series, so first of all, if limit n tends towards infinity, An is non-zero, then the series is divergent. Okay. And if it is 0, test fails. So this is the first test. You can check whether the series is divergent or not, right? If the limit nth term is non-zero. So in fact, if you don't want to prove it, it is fine, but at least I encourage you to find one example for each case, right? Try to find one example for each case. Now you can try to find an example of a series for which the limit n tends to infinity is non-zero. Then certainly you will see that the series is divergent, right? You're not able to find the sum. Okay. If it is 0, then as you saw, one side is true, right? If the series is convergent, another term goes towards 0. Another term goes to 0, you don't know whether series is convergent or divergent, right? Sigma 1 by n is an example where in case it is divergent, right? So basically one side it is straightforward, the other side may not be true. Okay. So this is first test. Next, nth root test. This is something beautiful test. If you take, so series is the same, okay? Summation a and n is equal to 1 to infinity. I'm not writing again. You just compute this limit n tends towards infinity. Limit n tends towards infinity. An raised to power 1 by n. If this is less than 1, convergent. Greater than 1, divergent. Is equal to 1, test fail. I will write shorthand TF, test fail, right? nth root test. Series is same, summation a, right? N is equal to 1 to infinity. This is our series. So I want to check whether the series is convergent or divergent. I will just take the nth root test, right? Okay. Got it? So if this is less than 1, convergent, greater than 1, divergent, and is equal to 1, test fails. Now there are a couple of laws actually which I want to mention. If the nth term contains x factorial or number of terms in un, number of terms in an increases with n, then we apply what is known as ratio test. What is ratio? Okay. I'll tell you what is ratio test. And then there are different ways, ratio test or rabies test. Or one side there is a log test, logarithmic test, De Morgan test. Have you read these things? Huh? Higher log test. So ratio test, depending upon conditions, I will show you those things. Either you apply rabies test or De Morgan test, or other side log test, higher log test, and so on. And once these laws are exhausted, then you apply comparison test. I'll tell you what is this comparison test also. Once these things are fails, So let us show you. So first of all, this is known as P test. This series is convergent if P is greater than 1 and divergent if P is less than or equal to 1. Right? You might have encountered this test earlier. पढ़ा है कभी? Huh? Commerce calculus में दिए हुए, right? This is. That's why I have asked you to read those portions. I am not doing any of those proofs, right? But at least you read that section. I'm going to at least tell you the test. Okay, this is P test. Summation n is equal to 1 to infinity. And I love this function, you see that I can modify this function beautifully and a lot of interesting things can happen. Anyway. Okay. Then we have comparison test. What is this test? If there are two series, say sigma an and sigma bn, n is equal to 1 to infinity, n is equal to 1 to infinity. Okay. They both behave. If one is convergent, other will be convergent. If one is divergent, other will be divergent. Their behavior will be same if n tends to infinity, an by bn is non-zero and finite. Comparison test. So this is many times this is quite useful. You just compare it with some other series and compute this limit, right? So the behavior will be same. So many times what happens, suppose you want to show using epsilon n method convergent of an, right? But then you find another series bn which is of identical nature but maybe simple terms, but this thing happens, right? Then you can use epsilon n on the second series to show, right? These kind of comparison tests are useful. Okay. So both these series will be of identical in nature. If this is convergent, that is convergent. If this is divergent, the other series is divergent, and so on, right? So those kind of. By the way, how do you prove this thing? That's an interesting thing. But as I mentioned, jiski jitni shraddha, right? I mean, it is not necessarily that you prove all of them, but you should know at least. Yes. Huh? Last line says that if limit n tends to infinity, a and bn is non-zero and finite. In that case, the behavior of these two series will be identical. Okay? If this is convergent, this is convergent, this is divergent, this is divergent, right? All those things. Then another very popular test is ratio test. So this is quite useful test actually, If, you compute this value an divided by an plus 1. An divided by an plus 1. And compute this limit as n tends towards infinity. Okay? So if this thing is greater than 1, convergent, less than 1, divergent, is equal to 1, test fail. Ratio test. In many cases of power series, we use ratio test. Okay. I think very natural example might be 1 plus x square by factorial 2 plus x cube by factorial 3 plus x raised to power 4 by factorial 4. This series, what is the value of the series sum? E to the power x. You know the convergent. I mean, everything you know very good. And this is convergent for every real value of x. Right. And you can use ratio test to show this fact. You see, apply ratio test, take the nth term, divide by n plus 1, take this limit, and you see that this thing is greater than 1 for all real x. So then series is convergent, right? So you can check. These tests are very useful actually, to show many things. Okay, then there is another Gauss test, which I am not writing it, but anyway. As I mentioned here earlier, so once you apply ratio test, there are two paths. Either you go to Rabi's test, De Morgan test, and so on, or logarithmic test or higher logarithmic test, right? So I'm going to show you formula for those things. Okay, Rabi's test. So what you do? If n times an divided by an plus 1 minus 1. Okay, if this limit is greater than 1, convergent, less than 1, divergent, is equal to 1, test fail. You subtract 1, multiply by the n, and take the limit. So which test to apply, that you need to make a choice based on the terms there, right? Then De Morgan test. If this test fails, you can apply De Morgan test. What it says that n times an divided by an plus 1 minus 1 minus 1 log n. And you just compute this limit as n tends towards infinity. If this is greater than 1, convergent, less than 1, divergent, is equal to 1, test fail. Okay, this is De Morgan test. All these things are given in Thomas' book, I guess, right? So, now if the ratio test contains e, exponent e, then you apply this logarithmic test. Okay, so what you do is the following. if you find term E there, right? So what you do? N times log of an divided by an plus 1 as n tends towards infinity. If this is greater than 1, convergent, less than 1, divergent, is equal to 1, test fails. Logarithmic test. You can also have higher log test, n log an divided by an plus 1 minus 1 times log n tends towards infinity. Greater than 1, convergent, less than 1, divergent, is equal to 1, test fails. So one test I have not mentioned here, which is called Frederick Gauss. Gauss has given a nice test. कुछ अपने आप भी तो सोचो, सर्च करो. Gauss test क्या है? Right. Paul Frederick Gauss was a great mathematician. As I mentioned, I have shown you the picture also, right? He has given one test, which is also very useful. But I think more or less I think in your JEE exam, you have done these things. That is beyond JEE, right? Calculus beyond JEE now we are doing, right? Sometime we are doing whatever is there. Anyway, so these tests are important, right? So one test I am giving you as a tea time problem. Call Frederick Gauss test. आजकल गूगल पे तो मिल ही जाएगा. चैट जीपीटी पे देखो, ट्राई करो, मिलेगा. तो टेस्ट मिल जाएगा चैट जीपीटी पे, राइट? सो यू कैन ट्राई. So how many of you tried those sample problems on chat gpt? Any help? Exam sample papers we have given, right? You found something on chat gpt? I'm just asking because I'm not sure. Is it good? Is it doing something? Try किया? अच्छा, अभी ऐसा होगा, you will start studying towards the end of the exam. That's a normal trend, and that's a very bad habit actually. As I mentioned, every week finish whatever is there, right? So that your ride is very smooth. Otherwise, first semester many people will bold, right? F, or 2.9 CPI, 2.3 CPI. Why? It's unnecessarily. Because there are certain rules. They will say that okay, you are not good. By the way, Ramanujan, as you know, he was, I mean, he was topper in high school, right? And then he took admission into bachelor's. Other than mathematics, where he got 100 out of 100, rest all places he was failed. He was thrown out of the university system. So that is also a possibility. But then there is a struggling path and a lot of fight. Finally, there was G.H. Hardy who picked him up. Otherwise, it's very see, normal people. There is a difference between genius and normal people. Normal people think that, and the principal was saying to him that you should pass in every exam. I want only average people. I don't want high-fi people. That's a right thing. But still, some of you want to look at his book, The Lost Notebook of Ramanujan, right? Beautiful problems. You will enjoy. Published by, I think, Springer, yeah. So you can get that book. Nice book. Okay. The Lost Notebook of Ramanujan. It's having beautiful, interesting things, especially mock theta function and so on. Many interesting. Anyway, so that's all about integral test. Maybe I should just briefly mention the Gauss test without actually doing anything. So an divided by an plus 1 is equal to lambda plus mu by n plus theta n divided by n raised to power 1 plus epsilon. इसमें कितने लोग इसको समझ पाएंगे? That is also a beautiful thing, right? This is the condition. If an by n plus 1 is something like this, C is a constant, by the way. Okay. Then the series sigma an converges if lambda is greater than 1, diverges if lambda is less than 1, and there is some condition on mu also. Okay. I leave it, the condition on mu. शायद कहीं तुम लोग ढूंढोगे, कुछ पढ़ोगे, इसी बहाने कुछ अगल बगल की चीज भी देखोगे, so that's good. Okay. Cost test. I think these are enough for you to prove find out the convergence or the radius of convergence of a series and all those things. You might have seen a lot of trigonometric series, right? Functions. Okay, so I think we have 10 minutes, right? So we can start the next stuff. So sequences, series, everything is okay. Now we need to talk about limit of a function. Right? ये तो पढ़ते आ रहे हो बहुत टाइम से. F of x equal to this, find the limit and so on, right? JEE का तो पूरा backbone ही यही था, right? So let us see how much you know. Limit of a function. F of x is a function, beautiful thing. We will compute limit of a function for a is some point on the real line, right? I'm talking about functions from real to real, right? Or some domain D, which is subset of R to R. D is the domain of the function, right? I mean, you can find out the domain of the function. You might have done all kind of exercise. So I want to find limit of the function f of x as x tends towards a. And this time, definition is in terms of epsilon delta. So the idea of the epsilon n, I'm going to slightly change. So what is happening, you see? Okay. First of all, here is your real line. This is the point A on the real line, right? Now what I do, I look at what is known as neighborhood of A. Neighborhood of some size. This is A minus delta. This is A plus delta. This value is delta here, right? Delta side on both sides, right? This is the point A. This is the neighborhood of delta, right? I have to design a definition of the limit of a function. Means if x is a variable which approaches towards A either from this side or from this side in the neighborhood, the value of the function remains. If the value of the function remains in the neighborhood of a fixed point L, we say that fx is the limit of. So we say that fx has a limit L. Okay, this is the basic idea, right? And as I mentioned, the distance between 2 points on the real line is mod of x minus y, right? If x and y are 2 points on the real line, that is the idea we need to keep in mind. Okay, so this thing can be written as, this is known as delta neighborhood of A. If you delete A, okay, so then it is known as, so basically this means what? Mod of x minus A is less than delta. Do you agree this whole thing corresponds to this? Because x lies between, A minus delta and A plus delta. If x lies between A minus delta and A plus delta, that means mod of x minus A is less than delta, right? This whole thing captures like this because the distance between x and A is mod of x minus A, right? So this is the key idea. Now, I need to show that. So I am looking at now deleted neighborhood. When we delete this point A here, and all other things are there. So then in that case, deleted neighborhood is, we call it as a 0 less than mod of x minus a less than delta. This is deleted neighborhood. Deleted a neighborhood means we are just not including the point A because of this condition. Right? X is not equal to A. So x approaches towards A, x is not equal to A. What is the value of the limit f of x as x towards A? In that case, what happens? If I take, I'm just, for the convenience, I'm taking another real line, but this could be the same. Here, suppose there is a point L, and here this is L minus epsilon, L plus epsilon. If suppose x is here, so x is here moving towards A, either from this side. I'm just taking, suppose x is here, then f of x could be anywhere in the neighborhood of L. If that happens, the limit of f of x as x tends towards A is L. Agree? So why? Because then what I'm saying, that in the neighborhood of L, the image lies in the neighborhood of L, either this side or that side, because epsilon is also a very small number. This distance is epsilon here. This neighborhood concept is very, very important, right? So if this happens, then we say that the limit of f of x as x tends towards A is L. Okay. So I mean, this can also be captured in terms of like this is in terms of mod. So this can be done. So this means what? L minus epsilon is less than f of x is less than L plus epsilon. That means mod of f of x minus L is less than epsilon, right? So that means mod of f of x minus L is less than epsilon. This corresponds to this, right? So this is enough for us to build the definition of limit. That we say that the limit of the function f of x as x tends towards L, sorry, x as x tends towards A is L, if for every epsilon positive, there exists delta positive such that mod of f of x minus L is less than epsilon whenever 0 is less than mod of x minus A is less than delta, right? From here, you can frame the definition, right? The idea is very simple. If you keep in mind the idea that epsilon n method, now we have epsilon delta method, right? Any question? So we can come back again to this idea, and then we'll show you. Now you have to compute the limit only using epsilon delta. No formula, right? So, and also prove that something does not exist using epsilon delta. That's what you need to get it, right? So that's all. Thank you very much. See you in the next class. Okay.